Greetings, everyone. Welcome to today's One Key Idea session on automated test velocity. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. If you have any questions during the course of the webinar, submit them at any time via your webinar interface, but please note that they are answered only at the end. So let's just jump right in here, shall we? Today's topic, as I said, is automated test velocity. So the easiest way to explain these things is with a graphic. And so what you see here in this said graphic, aforementioned graphic, is actually not just creation velocity. The headers should be updated, I guess, on the slide, but it's creation velocity and its update velocity, and it also shows validation velocity. That's the data sets that are in green. Now we're going to ignore the validation velocity for purposes of this discussion because it's somewhat industry specific. I want to focus your attention on the blue data sets and the yellow data sets. The blue is the test creation velocity, and the yellow is the update velocity. Now I say data sets because there's values recorded as of the end of each sprint, and then those are the data points that you see there in the solid lines, and then there's the trend over that period of time, as you see, is a little over 8 months. So what is being measured here is the number of tests created per person day in each iteration. That's what's being measured in the blue line. And it's number of tests updated per person day in the yellow line. So let's say that I have my test automators spend 20 person days, and we log the person days, 20 person days over the course of a iteration, which in this case are 3-week iterations, and produce 10 new tests. So that would be 2 tests per person day, and that would correspond to the blue data point that you see at the second from the left and on the blue solid line. The update velocity is measured similarly, but if a test automator is logging time against not new test creation, but the updating of an existing test, and we know how many person hours are spent during that iteration updating and how many tests were updated, we know a number of tests updated per person day of effort. So that's what's being shown there. Remember, person day, it's efforts, not calendar days, okay? So what we see here, if we focus on the blue line, is fairly stable new test creation velocity, slightly under 2 tests per person day. We look at the linear trend, it's holding pretty solid. There's some bumping around that's happening there, and that's natural because what this doesn't take into account is the size of the tests. So notice that we may have a situation where the tests that needed to be automated, the ones that came up at that point in the automation test backlog, were fairly small, and so we got through a lot of them, and that might explain the data point that's at June 2018. Is a fairly high velocity, that particular iteration, versus the if we looked at the furthest left, the slightly over 1 test update or created, excuse me, per person day there. So you are going to see some variability, some significant variability from one iteration to the next if the size of the test cases to be automated does vary. Obviously, you could try to normalize that somehow by using some sort of story pointing or some other kind of factor, adjustment factor, small, medium, large, and try to smooth that line out. But if you're doing 2-week or 3-week iterations, as these guys are, even maybe 1-week iterations on their automation, um, it may be the case that you've got enough happening there that you can just use the linear trend, as I did here, to smooth that out. So new test automation, the creation of tests, that's holding pretty solid. As I said, pretty stable at about slightly under 2 tests per person day of effort, about 4 hours, 4+, a little over 4+ hours per test to create it. Now, if we look at the yellow data set, again, I'm asking you to ignore the green stuff for the moment. We look at the yellow data set, what we can see is that the velocity of maintaining the tests is going down. It was pretty good for the first couple iterations that are shown here in 2018, but since then it has dropped pretty significantly. Now it does seem to have maybe stabilized in a new band here, and it would be interesting to rerun this analysis and exclude the first 2 data points that are there, because they may be tipping the line upward on the left side to create an impression of a downward trend. But what actually may have happened is that it just there was some kind of fluky sort of behavior going on in the first 2 iterations. Hard to say, would take a little more analysis to figure out. Certainly, if you see a downward trend in your maintenance, that is your maintenance or update velocity, that is cause for concern. You want to go in and figure out, okay, is that trend just sort of an optical illusion that's created by some spikiness in the data, or is that something that's actually happening? In this particular case, one of the things that made me concerned and made me caution my client was that there was some evidence that a best practice of test automation, which is the use of reviews, peer reviews of the automated test prior to declaring them complete, that process had been set aside after initially being in place in order to try to accelerate the new test creation velocity. Now, as you can see, the new test creation velocity has remained fairly stable, but there's a possibility that the price being paid there is issues associated with maintainability of the tests. So these are the things you want to look for. You want to look for changes in the relationship between the new test velocity or test creation velocity and the update velocity or the maintenance velocity. Now let's look at a more striking example of that on the next slide, where I was able to say to the client, there's definitely a problem here. Get it to advance to the next slide, that is. There we go. Okay. So here we just see creation velocity and maintenance velocity, because don't have the validation there to ignore. In this chart, there is definitely a problem, because what we see is the creation velocity. So again, this is tests per person day of effort. And here again we see, and this is just purely coincidentally, that the creation velocity tends to be pretty stable at 2 tests per person day, similar to what we were seeing before. Slight amount of variation, a slight increase there, and too early to say whether that's like for sure a trend. But what is troubling is the fact that the maintenance velocity is only slightly higher than the creation velocity, and they appear to be converging. There are actually 2 months where the maintenance velocity was less than the creation velocity, and 1 month where it was less than the average creation velocity overall. So you can see that the red lines there dipping below the solid blue line and then dipping below the dotted blue line or dashed blue line that represents the average. So that's definitely, there's trouble here. It should be easier to update an existing test, easier and thus quicker to update an existing test than to create a new test. But what we see here is that there's barely any difference, and that difference is vanishing fast. This is a classic kind of warning sign of a typical death spiral in test automation, which is where it takes as long or longer to maintain an existing test than to create a new one. And indeed, when we dug into what was going on here, we saw that there were coding standards in place that were allegedly being enforced, coding standards for the automation scripts, that is, that were allegedly being enforced by reviews. But of the scripts that we saw, the example scripts that we saw flagrant violations of the coding standards. And it was made worse by the fact that there were actually 2 conflicting coding standards, because there were 2 different documents that people were supposed to read as part of getting ramped up to be automators, and they had conflicting coding standards in them. But we were able to find what the problems were, not just where those things were in conflict, but even where they were in agreement. There were clear violations of that. So the review process that's allegedly happening was apparently either not happening, or it was happening and was utterly ineffectual. So that was a problem. And my warning to my client was, you guys are about to find yourself in a very, very difficult situation with your automation, where you're going to end up having to drop a bunch of it. Now, interestingly, if I told you, like, one of these clients was using a industry-leading off-the-shelf or open source approach to doing automation, specifically Java with Selenium, and the other was using a custom-built custom-built tool that they had created from some programming languages. I think it's called Qt and C#, and with robotics plugins to it. Now, which one do you think was the one that was having maintenance trouble? I'm guessing that most of you would guess, oh, well, it's the one that's using the custom-built automation tool, and they probably design themselves into some sort of test maintainability cul-de-sac. But in fact, it's the other way around. The folks who are using the tool they had created for themselves, again using Qt and C#, were the ones who were in better shape. That was the previous slide. This slide is a client that's their automation firm that they were using was using Java and Selenium. So, very well established rules about how to achieve maintainability in that circumstance. Yet, best practices only help you when you practice them. Okay, so those are the 2 metrics I wanted to show you in today's One Key Idea. It's very simple. As I said, all you have to do to track these is when an automator spends time doing automation, they're asked to track their hours and assign those hours to one of 2 categories, either maintaining an existing test or creating a new test. What you should typically expect is that a test automator will probably spend out of an 8-hour day, 4 to 5 hours doing actual automation work. That does not mean they are lazy. That means there's email and there's peer reviews, which are very important, as I've stressed here, and there's meetings, daily stand-up meetings of various kinds in organizations, and other things that one must attend to. So, so certainly, when you start telling people you're going to track, you want them to track their hours, there can be some defensive reactions to that if they're afraid that you're going to try to hold them accountable to a particular number of hours per day or per week or whatever. So what you want to do there is make sure that people understand, no, we're just going to use this to keep track of how we're doing in terms of, are we achieving steady velocity in terms of creating new tests, and is our maintenance significantly faster than our new test creation, and try to assuage people's concerns about that. Okay, so as usual, I will go to the advertisement, put the advertisement here, and take any questions that might come in. I had some advanced questions with respect to this presentation. One is, what is a good velocity? Well, it's just purely circumstantial that those two organizations happen to have similar test creation velocity. They're really, you can't put like a solid number on that of like what's the number of tests that one should be able to create in a particular person day of effort. Differences are too significant from one organization to another frequently, especially if you're maybe automating through different interfaces, right? So you would expect that your rate, if you were looking at tests that were automating through an API, maybe you're doing behavior-driven development, and you've got the ability through scripting to hook that into APIs and run your tests through APIs. Well, you probably expect that the number of the given when thens that you were able to get through the Gherkin syntax for a test, and you're testing via an API, might actually be pretty quick. We get a fair number of those because the granularity of each test is very, very small. Whereas the two examples that we saw, the granularity of those tests were larger because they were end-to-end transactions in systems. They were trying to do something. So the point is not to have a particular number as a velocity and say, oh, well, that's good because it's a good number. The point is really trends and relationships between the two data sets, the update and the create. So you want the create to be fairly fast, but you want the update to be significantly faster than the create. Otherwise, it's an indicator of maintainability problems potentially. And you also want the trend for both of those to be either flat or trending up. So you're getting faster at creating your tests. Okay. Still open for questions if anybody has them. I'll go on to another advanced question that was asked. How do I measure test automation return on investment? Is this a way to do that? No, these are not ways of measuring that, though they are part of the equation. They use data, which is part of the equation that is used to calculate test automation return on investment, typically, which is to say the effort associated with creating tests, the effort associated with maintaining tests. You also have to look at the effort associated with executing tests and comparable effort doing that manually. Now, you're in luck if you were wondering how to measure test automation ROI and whether this would point you in the right direction. It points you in the direction of gathering some of the data And there's also another One Key Idea webinar on this exact topic of test automation ROI. And if you look at the RBCS YouTube channel coordinates that are shown here, and also the RBCS podcast channel coordinates, you can see that you can find where to give those a listen, to give that ROI webinar a listen. Okay. Speaking of the podcast, just point out that some of these webinars are more podcast friendly than others. This one, if you are listening on the recorded podcast as opposed to live right now, you may have said, "Well, this is kind of tough sledding because I don't see the pictures." So what I would do is encourage you to go out to the RBCS YouTube channel and just take a quick look at the figures, which you can find there that for slides 2 and 3, as you're maybe listening to the podcast. Now I have a question here from Claudia saying, would you please explain the validation velocity, which you left out so far? Okay, let me go back to that. I don't want to spend a lot of time on it because this is not likely to be applicable to many of you. But in this organization, after a test is created or updated, somebody other than the test author has to go back and check the test against the requirements, the user stories and acceptance criteria effectively, that test is covering. And the reason that has to happen is for regulatory compliance. There's a rule that says the tests have to be validated in order to be still considered acceptable tests. So if you are in a regulated environment and you are required to validate your test, that may be something that you also want to look at. Or what you can do is just count the validation effort as part of the person hours to either create the test or update the test, depending on whether the validation is associated with a new test or an updated and existing test, respectively. Okay. We'll go back to the advertisement. Whoops, sorry, miscue on the UI there. Okay, very good. Well, I see no further questions. I'll go ahead and wind this down. I hope you enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We are happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. That's info@rbcs-us.com.